We welcome Karthick Gururaj to share his insights on overcoming the challenges of adopting software-defined vehicles and vehicle electronic control units. Everybody put your hands together in welcoming Karthick.
Morning, everyone. So, I think you saw the joke on the next slide when I was testing this, but that's okay. Overcoming it's not the IO, but it's 10 adoption challenges for SDVs using what are called virtual ECUs, vECUs. So I'm a simulation guy, so I'm been doing this for like last 25 plus years, and it was great listening to speakers before me. I noted the references to digital twins and importance of simulation for solving many of the challenges we as automotive industry face, right? So I would like to touch upon some of those in my presentation today. So why 10, right? So it kind of allows me to rehash this old joke which you just saw. So anyway, so I'm not going to stop with 2, it's really going to be 10. The slide seems a bit stretched, but I hope it's all mostly clear. It was not meant to be, it was not designed for this resolution, but anyway. Let me move this a bit so I can also see it. So, I'm not going to kind of make this a session about what are virtual ECUs, but I think it still serves to have a quick reminder before we kind of go to the actual topic. So, these are, I would say, part of the digital twin. The digital twin is like the overall umbrella, I would say. And what we call as virtual ECUs is one part of it, right? And what it does is essentially it creates simulation models of your ECUs that allow you to do something useful in some way, right? So that's the whole idea. And so you could, excuse me, you could potentially ask, what gets simulated? When I say it's a simulation model of ECU, you can definitely ask, okay, but at what level do I simulate? And what can I use this virtual ECU for? So these are the 2 questions we tend to ask when it comes to virtual ECUs. That leads us to this next slide, which again, probably many of you may have seen. It's kind of adapted from a white paper, right, that came from ProStep, I think almost 10 years back. So what you see in this slide, as you go across, from left to right, you're seeing different levels of what we call as virtual ECUs. And again, I'm not going to spend a lot of time today here talking about how these levels differ and so on. But the main takeaway is that as you go from left to right, we can actually verify, we can use the virtual ECUs for verifying more and more software, starting from just application level software, like control systems software, to all the way to full software integration, including the MCALs and BSWs and so on, if you are talking AutocarProIndia Classic, right? But obviously, while you can test more and more software as you simulate more and more details of the ECU, it does mean that the development cost for creating such a virtual ECU is going to increase. So the cost of creating these virtual ECUs is going to increase as you go from left to right. And also something else has to give, and that is simulation speed, right? Your speed at which you can simulate your virtual ECU is going to reduce. And so those are the 2 main factors, I would say, in defining, what level you would kind of pick the virtual ECU for your use case. But again, I don't want to dwell a lot into, the characteristics of virtual ECU and, how does one go about creating one today and so on. So I would like to instead spend the remaining time that I have talking more about what does this mean. Let's somehow assume it's a sort of a magical word today where we have virtual ECUs for digital twins for all our systems, right? And again, there are challenges there. Again, the panel earlier talked about the cost of setting up such flows, right? So, but let's assume it is all done, and let's ask ourselves, okay, what can I do with it? What magic can I create? What problems does it solve, right? So I would like to kind of focus on that message here. And again, to reiterate, I'm not an automotive guy. So for me, automotive software is, while we've been doing it for a few years, I primarily identify myself as a simulation person, right? So this is my perspective on how I feel, virtual ECUs can really address some of the outstanding problems in, automotive or SDVs today. Feel free to contradict me, differ with me, add to what I've got to say. That's all perfectly fine. Again, I'm not sure if it is very clear. Its fonts are a bit stretched, so apologies for that. I will read it out a bit if it's not clear. So there is I do need to turn around a bit. Sorry about that. Yeah. So SDVs, right? So one of the defining things is that you just have tons and tons of software. You have lots of software going in the car. I think I've seen analogies that try to compare the millions of lines of car that goes into the car with everything else, and automotive beats them sort of hands down. So with that, you have to deal with increasing size of your software team, and these teams are sometimes spread across geographies. You also are seeing new ecosystems popping up where you have these software suppliers that work possibly even a different organization, but you need to integrate as an OEM or as a tier 1, you need to integrate your software with them, right? So you're facing all of these challenges where, how do I kind of change my process, development and verification process to accommodate this new reality where we just have lots of software, right? So that's, I would say, definitely one of the main challenges. And if you kind of think a little about how it has been done so far, one might have used, I would say, pretty expensive hill setups to do some of this verification, integration and verification. So does this really scale with the requirements of SDV, right? So that could be another question to ask. And again, we talked about maybe liabilities just some time back. The need for functional safety comes into that. And some of the requirements in functional safety could be just a far better test coverage, right? And how do we ensure that happens? How do I make sure that all the error cases are covered correctly and so on, right? So that could be another one. And these are all challenges that we are seeing, is existing today. And we are seeing people, kind of grappling with it right now. And of course, with functional safety, another thing could be what does it mean for cybersecurity, right? Increasing software means just increasing attack surface. And that means, if my phone gets hacked, well, yeah, definitely not nice, but, if the car I'm driving gets hacked, that's like far worse, right? So definitely a big criteria. And software is never done, right? Software, we know people who still, maybe write business software in Fortran, right? So software doesn't really die, unfortunate maybe. So what it means is, software development for your SDVs is not going to end with shipping the car, right? So we are talking about a continuous evolution of software, and how do I make sure that every change I do, whether pre or post production, every change my software team does, how do I make sure that is fully verified, it is not breaking something that's already working? So we're talking about flows like setting up flows like CI/CD. How do I do that, right? So virtual ECUs does help in some way or the other with all of this. So for instance, again, I think that there was a mention about how software teams are spread across geographies in the previous discussion. I mean, virtual ECUs is like something in the cloud. It's something you can easily share across organizations, across geographies very seamlessly, right? And when it comes to, I would say it does complement hill setups, which are definitely needed. But by taking more and more verification cycles away from hill setups, you're going to use these more expensive, test equipments for really the things that they need to solve, right? So virtual ECUs help you in kind of doing cost-benefit analysis. It gives you more tools to do a better cost point, right? Then going back to functional safety and cybersecurity, some of the unique things you can do with virtual ECUs is that you can easily simulate error conditions, which are otherwise very hard to be done in real hardware. Now, as a hardware ECU designer, you tend to make whoever supplying hardware to you, they try to make it obviously foolproof. They try to prevent errors. There are things there that are there intended to prevent errors. Maybe some frame corruption. Okay, something happened, but anyway. It is there to prevent errors, right? So it becomes actually hard to test the software that has to react to errors in a graceful way. With virtual ECUs, you can play God, right? So you can say, I want to kind of pause this simulation. I want to corrupt this bit, or I want to corrupt this frame, and you resume and you see how your software reacts to it. Does it do what it's supposed to do? So these are all things that can be done. We have today, this is not hypothetical. We have customers today that are using virtual ECUs for, checking their safety cases and so on. The same arguments, of course, applies to cybersecurity as well. You can't maybe read it there. But again, virtual ECUs makes it very clear, very easy to even identify and fix vulnerabilities. So that's something very unique about it. In having an environment that can be nicely sandboxed, you have as a developer, as a tester, you have full visibility on all the states, which helps you kind of identify and test vulnerabilities very quickly. That's not moving. Sorry, it's not working. It's working? Oh. The latency maybe. Okay, the last point is on the slide is on the CI/CD, right? So again, being able to have a virtual setup where you can check every commit. It's very easy to make sure that all the changes, how the software is evolving, meets all your test and reliability requirements, right? So going on, right? Just let me actually skip the animation. Okay, so that's one part of the story, right? The other one could be, if you're talking about, how does your OTA process needs to be verified. So there are again many requirements here that one needs to verify, check, are there fail safes implemented correctly, rollbacks and things like that. So with what is called the L4 virtual ECU. That is the most detailed virtual ECU, the one on the right side of the previous picture. You can actually run this exact same binary that would run on your real target hardware. You can run that on this virtual ECU. This allows you to test things like, including things like secure boot, signing, firmware signing, whether it's done correctly. You can again do error injection, check if rollbacks are working fine, and so on and so forth. So all of these requirements can be met using virtual ECU as your test bed. Maybe one slightly different use case would be, let's say you have a real ECU now. Let's forget about virtual ECUs. You have a real ECU. you want to maybe test it. One of the things that you typically do is perform rest bus simulation, where maybe you have a test bed that is injecting some kind of CAN frames. But we have seen cases where we need more meaningful test bench, sort of functionality, right? Just rest bus simulation doesn't cut it. And we want to do this as a precursor to a full system integration, right? And here, virtual ECUs can play a part of the test bed for the real ECU by providing meaningful interaction with the ECU during the entire verification process. I think the last the last three bullets here are sort of straightforward. Again, in terms of time to market requirements, or what we call as shift left, where we are talking about being able to start your software development and verification practices much earlier. Virtual ECUs are definitely a great tool to have. This allows you to reduce what we can call as the cycle time, the time from when you're deciding to start the product to when you can actually launch it. This time you can reduce because you're eliminating dependencies on hardware, right? So that's the whole point of the shift left methodology. And of course, I think others. Okay, now you can see the slide. So definitely with the scalability that comes with virtual ECUs, you can do a much better planning on the cost. And yeah, I think I've kind of covered everything. One point I did want to add here is more when it comes to the newer architectures, right? So which I see the next panel might actually cover. So one of the changes we are seeing, of course, is some kind of consolidation of ECUs into more HPC systems. And then you talk about having maybe containers and virtualization on top. Virtual ECUs kind of lend themselves very well to these kind of new architectures as well. So that could be another thing, right? So that's about what I have for you today. Okay, I'm still trying to figure out this. So yeah, the reason for 10 is also one more reason was, I think we are close to Dashra, so I just wanted to wish all of you, happy festivities. And yeah, that's it for me. Thank you.